middle section is one, so there's
Oh, there we go. That's pretty good.
How's that working?
It kind of looks like a zombie game.
it works. The flex does make it kind of makes extra marks, but
Okay.
it doesn't have those big long lines now.
That's good.
That's not too bad. So those are the extra marks. Right. Just very good.
Well, you need a parallel design linkage.
Yeah. And I thought about that, but it wouldn't have been ready. I just want to test what I did. Finite amount of time at actual machine.
Yeah.
All right. The next goal for me is to then run program longer. But after that, it's swap out the servo.
I have pieces, you can probably pull one together.
Okay, I guess I'll get started on this thing. Up, Mike.
Okay.
Not much. Apparently, you finally you decided to bust out the Pixel first.
Yes, I got my ESP32 board put together over the weekend, so
I looked it up. There's actually no there's no level shifters or anything involved. There's literally just wiring it to
right. Yeah.
but you're like, oh, I need the pre-made board.
No,
It's
I
like,
didn't say I needed it. It's just my friend Brian was sending me one for free, and so I didn't want him to send it to me and then not use it. So
because I looked it up. I'm like, yeah, it's literally just wiring. And there you go.
yeah. Yes, very very simple. It's there's nothing to it really. Okay. So I guess I should probably take the batteries out first. So for people who haven't seen these before, this is hard plastic. It's not like fake leather. I guess it is fake leather, but it's not leather. It's hard plastic. And it has fake zippers molded into it. But with real fake leather. I don't know what they were thinking. And it looks like there are just 6 screws here to start with. All right, it's still hanging on here. I think this is going to be a faster teardown than I expected. Okay, so we have that. Oh yeah. Okay. So here's our matrix. Clip these wires here. I don't think I need those. Hello, Jake from State Farm. So this is a 3.5 millimeter audio jack, and this is how you input your data to this thing, which is kind of weird, right? But that's how you do it. So you plug in your tablet or your phone or whatever. You plug this into the input port, not the input, the headphone jack, and there's an app and it just plays audio through your headphone jack, and the audio is like the data. So it's kind of like old school, but yeah, it's kind of like those acoustic modems in a weird sense. It's like not an acoustic modem. It's like a telephone modem, like when you had dial-up. Okay. All right. So that's it. Like, the matrix is out. And I might save this. This is like a little diffuser. Yes, just like a square for merchants. And I don't know. So this is the controller that they're using, and I don't want that on there. And it's got some wires that are the positive and the negative wires. And I think I need to save those. Hi. I don't know how you pronounce your name. Is it Mary? Is it Myri? I can't parse the pronunciation based on the spelling. Okay, so we have our matrix out. That was really fast. I don't know what is... We've got a little black blob here, as you might expect. And there's some unused components on this board. See, we have a coil on this side. Maeri? Is that close to right? Maeri? But on this side, there's a spot for another coil. I don't know what that other coil would have been for. It's a mystery. And we've got some SMD components that I don't know offhand. But yeah, we have a little coil. We have the black blob. We have a crystal oscillator. We have capacitors. So this is probably going to get trashed, though maybe I'll save the switch. And I don't think there was anything else of value. Oh, yeah, there's a little one of these like silicone tactile button things that maybe I could use for something. So I think I need to just start trying to connect this up to the ESP32. So let me go grab that. What would you do with the black blob board? Would you decap it? Okay, so here's that ESP breakout board module. And I think this is just about as simple as plug this cable from here to right here. And then I need to connect these power leads to right here. So we'll strip these wires. How would you program it? I mean, I guess maybe you have access to the programming pins here, but I don't know. None of it's. I mean, the pins going to the LED matrix are labeled, but the other pins aren't. I guess you could just probe. All right. So let's get these in here. No, I don't see a JTAG connector. I don't. To be honest, I don't know what a JTAG connector looks like off the top of my head. So let me look that up. JTAG. Yeah. No, I mean, unless you're reusing this, but this is all that there is, right? And this is just a piece of foam. So you have this that goes to the LED matrix. You have this button, and you have this switch here. Oh, what does this say?
You're going heavy industrial.
Yeah, no, there's no identification, and it's potted.
There's
No, these wires are labeled battery plus.
this
One of them's try me. That's the like try me button on the front. V33R. I don't know what that is. Switch 1 off and ground. So
encoder,
I don't know.
17 motor, real fast bearing, real wing screw. Actually, it's folding. So this would be one possible. It is sitting. And this is somewhat smaller, which is mark the size of this printer.
all right.
Yeah. Another one needs around somewhere. Yeah, I do. But maybe this is it.
Let me put this down so one and you drop it over the mic.
Okay. I think the ESP32 is fully connected. Hey Dean, how's it going? I think the ESP32 is fully connected to the matrix. So, Brian, the creator of this board, told me there's some like configuration to do here. Let me check what he told me. See, there's these little switches, and there's a jumper, and I'm supposed to put these switches in this jumper in a specific position. So let me see here. So change the jumper to diode bypass. Okay. And I'm supposed to put B and C on the switch to the down position. But then he corrected himself and said that it's not B and C, it's C, D, and E. So
There's this here.
D and E are down. All right, let me find a USB cable and let's see what this does.
More than that, you got that where the little plate, that's when we mounted. The big one's when we move.
This is pretty
No. There's a couple that are going to put together, but I think that's what you're trying to do. How much travel you need and having it not extend below the end. That's the hard part to see. Without having the whole thing go up and down.
Okay, so
If I actually mounted it this way, it would just just be in the way of here.
All right, ESP32 is on. Can I prop this up somehow? All right, it'll stay like that, I guess. Okay. Serial board. ESP32 dev module. Is port. There's like, when you go into ESP32 mode in the Arduino IDE, there are like a bunch more options, which is interesting. So now Brian told me I need to set my, what did he say? I need to
Move the whole thing up in there with the spindle attached to the tip of it. That way you get 10 or 12 inches of Z-throw.
I need to change my constructor,
That's even 7.
and I
that's
need
not
to
even 17.
set the scan rate. So, I don't know what that means.
And it's time spot and it's actual ball bearings. So it's
Display begin.
you can push down on it. It's
Define your display layout here. Let's try uploading and see what it
They
does.
have this bracket thing. When they're done, it's shut off the motor, stick the thing under it, and it sinks down until it's just.
What is this?
Okay. Search fitting.
So it takes a lot longer to compile this ESP32 sketch.
But that would give you 12 inches or so of Z-throw.
Yeah.
You see a spot for 4 pins on the board.
Project ahead of night. 3 inches of travel, and that's on the actual work piece. So you have full length offset or work piece.
I do not. I see. Oh yeah, look, there's
You can retract that.
so over here we have
The tip of the spindle will be
VPP ground, SDA, SDK, or SDA, SCK, and 5 volts. So maybe those. I don't know.
down.
Done uploading. All right.
No. No. Well, your
So-
X will-
It
the more
uploaded.
mass you have, the more your X
But-
acceleration will.
My matrix is not on.
Right now, it's pretty rigid for its mass, so it kind of moves the unit. The more mass you hang on, the more it's going to flex. Again. So we might, have to lower.
Yeah. So the SCK, SDA, this spot for a header right here. That's what you were talking about.
So it has bracket,
Okay.
top and bottom.
Thanks. Beta fruit. LED matrix.
Well, they're both left.
Sorry, this isn't the most exciting. I'm doing a little reading here to see if I can figure out
Trying to get that.
why this thing's not running.
So the same rails will have to stand up.
See all buttons. Not to a Raspberry Pi.
All of the motor and everything.
Mm,
It's not like
I mean, if you really want to program one of these, the stupid purse is like $9 and change. So you could get yourself one of these purses, and then you'd have the matrix to play with too. Because without the matrix, what are you going to use this for if you program it? Hello, Maker Block. So for Maker Block, who just joined us, I have this ESP32 connected to the matrix, and I have the sketch uploaded to the ESP32, but the matrix isn't doing anything. So I'm trying to figure out why. And yeah, this is not terribly exciting because I'm just reading.
No, that's legit. That's that the thing you have your hand on right now? No. The thing you have your hand on. The end part. Talking about there. There in that end? That. The lower part of your fingers touching. Your pinky finger of that hand is touching. That's an actual press there.
Okay, so this takes a load.
That takes a load, not the motor. The motor just tries to store.
Okay, so the information there. This is this.
Yes. The 3D printers don't have
Yes, I have voltage to the matrix, or at least I should. I suppose I should get the multimeter and check to see if I'm actually getting voltage over there. But these wires here are supposed to be supplying voltage. So let me grab the multimeter and just check. I shouldn't assume.
all legitimate root screws and everything. That's devil.
So yes, there's 5 volts going to the matrix. So it's there. It's just not turning on yet.
You need a limit switch.
Hey, Rue. Yeah, that is not my lathe, but it is a very nice lathe. Hi, Arthur thing. I don't know how you pronounce that. Arthur, not Arthur, but Arthur thing. Rue, I feel like you probably have a really nice lathe. You seem to have a lot of everything, except you probably made your lathe. Like you probably built it out of pieces of iron pipe. All right, let me try something else here. Examples. Oh, okay. If ESP32.
setup, so you know your gauge length to table distance is going to be the same every time. It's more important on the Z than it is on X1. X1 is only important if you stop it out in the middle of line.
And
And that's only accuracy trying to get within 1 or 2 tenths of a millimeter. Not that important, but you can do that with a good quality.
if def does not name a type. All right, I don't know what that means. No, it didn't die. I just took it apart, and so now I'm trying to connect to this ESP32, so it'll run off the ESP32 instead of off the stock controller. And I'm just trying to get it working, and it's being futzy. If def does not name a type.
They're also what's on that? That again, that has actually voted.
So they serve both.
Yeah, Rue.
They have encoder.
You want to see the if def. Okay.
So you come up, you hit the switch, and then you come out to the CD base. Once for rotation. So unless you put the index pulse where it's right on top of where the switch is, where sometimes it's in front of the switch and sometimes it's behind.
Okay, so Brian said I need to configure. What did he call it?
So the idea is to find out where the index pulse.
Said I need to change my constructor up top, which I assume is this. No, Dean, the ESP32 is not plugged into an Arduino. It's on a breakout board, and it's plugged into my Mac. I don't know how to show you the if def. I can't paste all that. I guess I can paste it one line at a time. Okay, that's the first if def, and then there's a bunch of definitions that come after it that are like. After that, there's a bunch of things like this. But then, after those comes another if def for an ESP8266, and then it has a bunch more definitions. And Brian told me, he said, quote, "You just need to change the constructor up top and the scan rate in the setup." And I don't know what that means to change the constructor up top. I might, Roger, can I pick your brain for a minute? Okay, so I have these things connected, right? And Brian said, he said, in this sketch that I'm using, he said, you just need to change the constructor up top and the scan rate in the setup. And so this is the sketch, and this is the constructor, right? No.
The scroll down further. The constructor is in the where you call the create an object. Okay, we're almost there.
Okay.
Scroll down. So I think no, that's a method. Display ticker. constructor for what class? Is there a
I don't know. He didn't say. And now it's the middle of the night in
Probably.
Ireland, so I can't bother him.
probably the display class? So where did display get set up? So
Display.
where would if you're missing, you would say undeclared. There it is, PX matrix display. So one of these parameters is what he's talking about.
Okay. Oh, okay. So it's set on 32 by 16 already. So that's already set to what that needs to be. These would be for larger ones. Okay. So where was that bit that we were just looking at? So that's all we needed. That's what he meant by the constructor, right?
That's my best guess.
Okay.
But there may be constructors for other classes in there.
Okay. And then he said we need to change the scan rate in the display.begin. So that's display.begin. And does this make sense to you? We have define your scan pattern here, line, zigzag, zag is, default is line.
They look like reasonable defaults.
Yeah. Where do you see your the defaults being? Like, I don't. Do I need to uncomment this right here?
Well, I think that this comment is telling you that the default is line. So if you uncomment, this line would do effectively nothing.
Okay.
Because that's what it already was.
Okay.
But if you're going to turn it to zigzag, then you
I see.
uncomment and change line to zigzag.
Okay. Okay.
Is there a problem you're trying to solve right now?
The problem is that I've uploaded this sketch,
Yeah.
and it compiled fine and it uploaded fine.
Well, I see an error on the screen right now. What is that about?
That was because I was fucking around and changing things.
Okay.
But I should have put it back the way it was, and so it should work now. So it compiles. So
Okay.
ESP32 is powered. The data cable is hooked up. The power lines are hooked up. 5 volts is present here on the board, but like the board doesn't display anything. So I'm trying to figure out like why is the board not displaying?
Okay.
And it's possible, I guess I could try flipping some of these. He said that like he couldn't remember exactly how these are supposed to be flipped. But he said he thought that it was C and D, or D and E that have to go down and C has to be up. And then this should be on diode bypass for this. So, but if 5 volts is going to the board and the data is going to the board, then I don't know. Do I have a link to the code? Is the cable keyed? Yes, the cable is keyed. So there is only one way it can go in. Are the cable ends flipped? Are your pin defines set correctly? Is define 16 PLAT is 16. Yes, thank you, M. Mosba.
Not quite amoeba.
No. So what is going on here?
Do you have okay, so this is a in, and then there's the daisy chain option out.
That's right.
Is there a no? Is there? I was going to say if there's 5 volt on that, you can test to make sure there's 5 volt all the way through.
I did not check over here. I checked right here.
Okay.
I don't know where else 5 volts would be on this board besides right there. But it doesn't. I mean, if you daisy chain it, I'm not sure that the daisy chains the voltage, or if it just daisy chains the data.
Oh, the data.
Yeah. So. Amos. Okay, that makes sense. Well, I guess I can try the Adafruit sketch. Where are you?
they down through the day. So,
No, I don't know.
working.
Yeah, that was the stock.
So it seems pretty destructive. You can't hook it back on to see make sure it still works.
I mean, I could. I could just plug it back in, and then this is this was going off to like another peripheral, so I just have to solder the like power lines back on, and then plug the cable back in. But no, I mean, I can't just simply do it right now. I have to like change some things, solder some things.
So not the best option, but it is still an option to make sure you haven't cooked something.
Yes.
Okay, well, we'll leave that as a to-do list.
I mean, hopefully I didn't cook anything. There's not much to it besides like put your power leads and put your data cable. So oh, I just saw a flash. What was that all about? Oh, there's one light on. Hey, look, there's one light on. Maybe we just have a
Loose connection somewhere.
yeah. Maybe we just have a loose connection.
Wait, okay. Were you you were compiling, uploading something, right? Did that just finish and upload it?
I did not. It compiled, but I didn't upload.
Okay.
But
Well, these two lights were not on when I walked up,
okay.
so something did just change.
Yeah.
Well, I'm a computer person. Have you tried turning it off and back on again?
I have not tried turning it off and back on again. I guess I can try that. Let's unplug it.
Where's the where's your other 5-volt power source?
My other 5-volt power source.
There's no way all these LEDs are gonna run from a USB port.
Okay, so Brian said that with the like sketch that's on there, it will be okay to run off the USB port. He said if you start getting crazy and you want to have them all white, then like that's not going to be enough. There's not going to be enough current. But he said just for the sketch that it should run.
All right.
So, but I suppose it's possible that we just don't have enough voltage.
So you've checked and there's 5 volts, not like 3.8 struggling to run.
Yes.
Okay.
Yeah, there was 5 volts over here.
Okay.
So yeah, it's well, we reset it and we have one light still. So it might just be that it needs more power than it's getting. So I guess I could grab the power supply and give it 5 volts and see what happens. So why don't I try that? All right, power supply time. Yeah, Rue has been around for a long time.
number on the end. 25%.
Yeah, only one 2,000, one out of 2,404, 2,048. Only that much more to go. 2,047. Okay.
Well, I mean, I say, it doesn't really make any difference unless he's fixed the software using the hardware to make the switch better. He's still doing it all in software, it's not gonna be any different. Better.
Okay, well,
Just gotta-
it's on the power supply now. And we don't have any. Yes, we lost the one light. And it's pulling a little bit. It's pulling 0.03 of an amp. Oh, look at that. Look at that. We got something. Hey, it's working. I don't know if that's. Well, it's kind of working. It's not exactly working, but it was doing something. Yeah, why? Yes, the one light is back. Yeah, I was checking the dip switches. There we go. There's definitely something fiddly here. All right, let's turn that power off for a second. And move this to diode bypass, or away from diode bypass. Let's give it power again.
One axis, neither axis is motion 0, and one is more than 10 times the length of the other. At one.
You know, I don't know what this program is supposed to be doing. It doesn't say at the top. It's
All it does is ensures that the short movement is
this is not the this is not Brian's sketch. This is whatever the damn. It's just called Pixel Time.
Who said the long conversion?
Let's try this one. This is just called Pixel Time, and it comes with the library for running these things.
Was power the issue?
No, but I got more than one light come on. There was like several bars started lighting up, but like I don't look. Oh, it was doing something again. There's like I don't know if there's something loose because like sometimes when it's in the right position, I start getting sprinkles of things going on here. So I don't really know.
I knew that these existed because I used them as the basic.
I guess, you know, maybe I should just unplug the cable and plug it back in.
Well, it's on. That's probably.
So, all right, we have some, we have something. Yeah, all my solder joints look okay.
Well, my plan with this is to have two big wheels like this on the bottom. About that far apart. Maybe a little one, I go one in the middle. And have to
Okay.
come up at an angle about like that. These,
All right, let's
like right
turn it off.
giant tractor.
I don't have another ribbon cable, but I will just try unplugging and reseating it. See if that does anything. Well, we've got that. It seems like, I don't know, it seems like it's getting data sometimes and then like not getting enough data to continue. Let's try putting all the dip switches down.
I've done what, at least 1,000 times.
No.
Well, that's on 720 lights, it's on the lighting. And it's not blinking, it's okay to unplug, right?
Yeah, I checked those IDC plugs a few times. I've seated them and reseated them, and they seem to be seated properly. They just don't. The thing just doesn't want to come on.
Hello?
Yeah, too late. Sorry.
Two lights starting.
Let's see. What else? What else?
Yeah, it's two lights starting. It's really tiny.
Configuring the dip switches. CD and A. You can check if the display uses these pins by checking if they have continuity with ground. Jumper block at JP1 controls da 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 da. Hmm.
There's almost no. There's almost no.
Yeah, I mean, I guess we could try some code rue, but I don't. I mean, it could be a bad sketch, or it could be. Let me see what the Adafruit sketch does. I don't know if I'm gonna have to change the sketch for.
So it's like ESP versus.
Let's see if it compiles.
You only have.
No such file or directory, so I'm missing some Adafruit library.
You have 2 ports.
Why?
You don't get to use the other port.
Manage libraries.
You get rid of but you don't have full access. To 2 ports. Basically, you're only you can get some of the functions on your laptop. There is actual operating system. It's just mostly video and there's like there is exportable functions.
Install. Okay.
It depends on how much network stuff you actually do. Library is easy library support. More random.
Yeah, this is the back of the panel. Let's see if I can flip it over there. So it's reversed. in the camera, but yeah, I don't know what you're looking for back there. Let's see if I can move that out of the way. There you go. These are very bright in my face.
You can add an SD card.
I just installed that thing. There's my ones.
You're gonna kill your flash. I mean, which is why you want to bring this card. And there's flash. A couple minutes, 3-4 minutes, depending on the board.
Yes, I do have an out connector. It's right here. I just haven't soldered it on because I don't have anything to go out to. I don't know if the sketch is addressing the right pins. I'm gonna have to do a little. I'm gonna have to do a little troubleshooting on that, I guess.
This is also an option.
So why does it say that's not installed?
I mean, you have these additional features. To add. You can't add this card.
Okay. All right. The Adafruit sketch is not working. It's missing some library. All right. Good night, Dean. I'm almost done here. I think we get kicked out of here at 8 o'clock, so I can't work on this too much longer. Got about 10 minutes left. Yeah. Maybe you guys would like. Here, let's take a poll. Would you guys like to see the pen plotter working, or would you like me to keep working on this? If you want to see the pen plotter, then we can go over there maybe. Or I can keep tinkering around with this. Yeah, Ro, I don't think we're going to be able to figure this out in 10 minutes. This feels like it's going to be a few hours of like looking through code. All right, Dan says pen plotter. Anyone else want pen plotter? Roger, how would you feel about showing the pen plotter on the live stream? Yeah, I agree, Mitch. I think it will require a bunch of reading. So why don't we go take a look at the pen plotter? I'm not going to hold the Z-axis because I jerry-rigged a Z-axis thing today. Well, Roger hooked up a servo, and then I jerry-rigged a bracket for the pen. So see that? That's my nice bracket I made out of some failed 3D print parts. So the servo just lifts the pen up off the paper.
This will be a good.
Yeah, sorry, James. We've made some improvements since last week. So
Let's see if this computer
there's
still working.
there's Roger.
Part of the test here is that does the system is robust enough to stay running, an hour or two after we turn it on, because there's a memory leak that causes it to crash. So it's been sitting around for how many hours now? 2 hours, an hour or two. And we're going to see if it runs when we just hit go, or if it's just going to die on us. Drum roll, please.
Yeah, you like that Sharpie?
Precision tools.
Use like an exact.
This is a machine.
Yes, the ESP is up there.
You can even see the direction and step pulses on LEDs.
What is HPGL, Rue? I don't know what that means. All right, there you go. There's a little demo of the pen plotter. What did you say? Hewlett Packard what?
Hewlett Packard graphics language is for pen
Hewlett
plotter.
Packard graphics language. Is that what it is, Roger? Is that what this is?
No,
Running?
we're running G code.
Yeah, this is G code. Yeah. So when the pen tilts up, they're commenting on the extreme lift up of the pen. That's just like one Z-axis unit. So like, how did you define that?
That's a parameter in Gerbil,
Okay.
and it's possible to define it as arbitrary levels of Z to see how far your servo travel is.
Okay.
And all I have right now is through a 90-degree arc. It's positive 1 millimeter, 0, and negative 1 millimeter. Anything less than negative 1, it just stays at the lower position.
Okay.
Anything greater than 1 millimeter is at the upper position.
Okay.
So if I want a more gradual move, then I would have a wider range and then have G code that doesn't
Okay.
move as far.
Okay. So that's some parameter. Yes, this is Gerbil, right, Roger?
Yeah.
It's Gerbil. Yeah, it's Gerbil running on an ESP32.
Mhm.
Yeah. So, yeah. People are saying that they're clapping for you. So,
Thank you.
someone also said that you're Bay. Who said you're Bay? James says Roger is Bay. So I think the long term, yeah, it is a compliment.
Okay.
I think the long term goal here is to turn this into a CNC, not a pen plotter. But the pen plotter is just a good way for us to test this thing. And I shouldn't say us because like Roger's doing almost all of this work here, not me. I just put together the little bracket for the Sharpie tonight. So oh, you guys are talking to each other. Okay, I think I'm going to call it a night for this live stream unless anyone has any other questions. Good night, Rue.
230 by 210.
Put a little Tesla coil on it and make it a wood burner. Yeah, we could do that. I have a neon sign transformer that'll like really burn wood. I was doing Lichtenberg figures with it last summer. But yeah, okay. Bye, everyone. Thanks for tuning in. Hopefully I'll get that board, that matrix running pretty soon, and I can have another video on that. Put a blue laser on it and burn Twitch subscribers. Okay. Bye, everyone.
I was going to say, or if you actually want it to work,